Hi guys, welcome to your last day of review week. Today we're going to review the Pythagorean Theorem. We will also cover this more in depth throughout the year, but I suspect you've seen it before and maybe remember it. Don't stress out if you don't, because I'll teach it again later in the year. So here we go. The Pythagorean Theorem is used for finding the missing side of a right triangle. Let's see if you remember what the Pythagorean Theorem is. Okay, has to be a right triangle with that little red square in the corner. Okay, the Pythagorean Theorem says a squared plus b squared equals c squared. Do you remember that? Okay, well let's see if you can do it from here. And if not, again, don't stress. We'll do it again later in the year. All right, the key for the Pythagorean Theorem, A, B, and C are sides of the triangle. The one that matters the most is C. C has to be the side that is the biggest, the longest side, and it's always across from the right angle. So if the right angle is here, straight across from that, that is C. A and B are the two legs or straight sides forming the right angle. So A and B are the two legs, and it doesn't matter which one is A and which one is B. So C is 17, that's what matters most. So 17 squared has to go here. A and B are the two others, and it doesn't matter which one you write first. So x squared plus 15 squared. Okay, that's the Pythagorean Theorem. It helps you find the length of a missing side. So now I'm going to square those two. I have x squared plus, remember I told you to memorize those perfect squares? Well, 15 squared, did you remember it? 225. 17 squared wasn't on the list. I forgive you if you don't remember that one, but it does come up pretty often. 289. Notice it ends in a 9 because 17 ends in a 7. 7 times 7 is 49. All right, get the x squared by itself. Subtract 225. And x squared equals, subtract that and you get 64. Take the square root of both sides, and x equals 8. Okay, so the last thing you want to do is double check that your answer is reasonable. If x equals 8, then picture putting that back on this triangle here. If the sides of the triangle are 8, 15, and 17, is that reasonable? And yes, that is. I mean, you wouldn't want to leave it at, the 64 before you square rooted it. That would be out. That would be way too big. And the 17 was supposed to be the largest side because it's across from the right angle, so that seems reasonable. You're probably only going to need, I think, one more example of this, unless I'm reading this wrong, in which case let me know by all means. Okay, so again, one missing side of a right triangle, so this is the Pythagorean Theorem. A squared plus b squared equals c squared. So a squared plus b squared, b squared equals c squared. And c is the most important thing to find. C is the longest side. C is across from the right angle. So in this case, c is x. So underneath the c, we're going to fill that in first, x squared. A and B are the two legs of the right triangle, the two straight sides, 12 and 16. So I have 12 squared plus 16 squared equals x squared. Okay, 12 squared is 144. 16 squared, you got to guess. I hope you at least know what it's going to end in. Okay, 256 equals x squared. Notice that for this problem, the x is by itself on the right side of the equal sign, so we're just going to add these up. So add 256 plus 144, and you get 400. So x squared equals 400. And take the square root of both sides. Okay, to get the x squared undone, you square root both sides. The square and square root undo each other. So x equals, not x squared, just x. Equals the square root of 400. Now maybe you know that that's 20 times 20, so it's just 20. And if you do, that's great, you're done. If you didn't recognize that that's 20, then you could have said, well, 400 is 4 times 100. The square root of 4 is 2, so it comes out of the radical. But the square root of 100 is 10, it also comes out of the radical. So it's just 2 times 10, or 20, which is a reasonable answer if it's supposed to be the longest side of that right triangle. Okay, I think I have one more example. Let's see what we got. Yeah, I thought so. I thought I had one more in here. And I'm pretty sure the reason I chose this is how you write your different answers. Okay? So we're still going to do the Pythagorean theorem. And for this one, C, my longest side, is 15. So a squared plus b squared, and it doesn't matter which order you wrote those two, equals c squared. So a squared plus 25, oops, mistake. Okay, x squared plus 25 equals 15 squared. You remember what that was? 225. Okay, subtract 25 on both sides. And x squared equals 200. Okay, now we're going to take the square root of both sides just like before, and we get the square and square root cancel each other out, so x equals the square root of 200. But that's not a perfect square. So you're going to write your answer two different ways depending on the directions, okay? The approximate decimal answer perhaps makes more sense in the context of this problem. The decimal answer may make more sense in the context of this problem because then I'll be able to compare it to the other sides. So the square root of 200 in my calculator this is what we write for approximately equal to 14.1 if I round it to the nearest tenth. And that seems like a reasonable answer. But this is high school geometry, not baby school geometry. So here's the other option for writing that answer, and that's why we learned yesterday's lesson. Okay, the square root of 200, if they ask you to write it in simplified radical form, then I would have to find two numbers that multiply to 200, where one of them is a perfect square, and those two zeros are neon flashing lights, 100 times 2. The square root of 100 is 10, so 10 radical 2 is the simplified radical form of the answer, and this is the estimated decimal rounded to the nearest tenth. This is actually, the radical answer is actually the more exact answer, and this is an estimate because we had to round a little bit. Okay, we'll work more on that during the year, but if you would, practice these next couple of problems. Good luck. I'll see your faces soon. Bye.